57 through 60. Find the probability of the given event. And now we're focusing on dice. 57. A die with 6 sides is rolled. Find the probability the number is less than 5. So we're talking about a single die. The sample space for a single die is just a set of natural numbers from 1 to 6. So to find the probability that a number is less than 5, we look at the 6 outcomes. Out of those 6 outcomes, 4 of the numbers are less than 5. So the probability of choosing a number that is less than 5 is 4/6, which can be reduced to 2/3. We can divide 2 from the numerator and 2 from your denominator to get 2/3. All right, that's it for 57. 58. A single die is rolled twice. The set of 36 equally likely outcomes is the set given to you right there. Find the probability of getting 2 numbers whose sum is greater than 10. So I'm going to use some lowercase s, and that means greater than 9. I say greater than 10? The sum is greater than 9, excuse me. Now, the highest sum you can have when you roll a single die twice, or 2 dice rather, if you want to look at it like that, is 12, which is 6 plus 6. Now, it says the sum must be greater than 9. If the sum must be greater than 9, that means that the sum is 10, or that's the probability that the sum is 11, or that's the probability that the sum is 12. Because having a sum of 10, 11, and 12 are all sums that are greater than 10. Sorry, greater than 9. So the outcomes that gives us the sum of 10 is 4/6, 5/5, and 6/4. For the sum of 11, that is going to be 5/6 and 6/5. For the sum of 12, that's only one outcome, which is 6 and 6. The probability that the sum is greater than 10, those are 3 outcomes out of 36 possible outcomes. For the sum of 11, that is 2 outcomes out of a possibility of 36 outcomes. And for the sum of 12, that is just a single outcome out of 36 possible outcomes. Remember, the word or means union. So if we used to unite all of these outcomes, that means we are to add the probabilities. And if we add the probabilities, the probability that the sum is greater than 9 is 6 out of 36, which equals to 1/6. We can divide the numerator and denominator by 6. Sticking with the 2 dice, or rolling a die twice, 59 says, when 2 balanced dice are rolled, there are 36 possible outcomes. Find the probability that either doubles are rolled or the sum of the dice is 6. Ooh, key word. Probability of doubles or the sum of 6. Remember, or means union. We just said it a minute ago. And when you want to find the probability of a union, that means you are using the addition rule. Hence, the probability of doubles or 6 equals to the probability of getting doubles plus the probability that the sum is 6. Let's write that better. And then you're going to minus that by the intersection of the events to avoid double counting, minus the probability of doubles, and the sum is 6. Now, when we say doubles, that means they have the same number on both the first row and the second row. So my doubles are 1, 1. Well, let's zoom in actually. 2, 2. 3, 3. 3, 4. Sorry, 4, 4. Excuse me. 5, 5. And 6, 6. So that probability is 6 out of 36. Do not reduce the fractions yet. For the sum of 6, that means the numbers must add to 6 when I roll the 2 dice. So that's 1, 5. That's 2, 4. 3, 3. 4, 2. 5, and 1. That is 5 out of 36. Remember, we're adding. Now, when it comes to doubles and the sum of 6, that is only one possible outcome, which is 3, 3. Because if you notice, 3, 3 is the only outcome that we repeated. It is the only outcome that is a part of both probabilities. So that means you have to avoid double counting in this situation. So that's going to be minus 1 outcome that is counted twice out of 36 possible outcomes. Same denominator, add the numerators. That is going to equal to 10 over 36, which equals to 5/18. And that is the probability of getting doubles or the sum of 6. So we're going to rebox that actually. I want the entire box. Okay. Number 60. Find the odds in favor of getting a sum of 9 when 2 fair dice are rolled. Oh, so it says find the odds in favor. Also, let me label this as question number 59. I keep the same kind of labeling technique. So you want to find the odds in favor. So the odds in favor of an event E that has A, favorable outcomes, and B, unfavorable outcomes, is denoted by A to B, or you can write that as A to B using the word to, or 3 as a fraction in simplest form, which means you have to simplify the fraction if possible. So basically, to find the odds in favor, you must find out how many outcomes are in favor of the sum of 9, and then find how many outcomes are not in favor of the sum of 9. Then we can construct the ratio. All right. So A, that means the sum is 9. How many outcomes give us the sum of 9? So that's going to be 3 and 6, 4 and 5, 5 and 4, 6 and 3. That is a total of 4 outcomes. So we have A equals to 4. Now B represents the sum is not 9. Think about it. There are 36 possible outcomes. 4 of those outcomes gave you the sum of 9. So that means the remaining outcomes is a sum that is not 9. So in this case, to find B in this case, I'm not going to repeat it myself. That's going to be the 36 possible outcomes minus the 4 outcomes that gave us the sum of 9. That equals 32 outcomes, such that the sum is not 9. So we can now write our ratio. To find the odds in favor, that is going to equal to, I'm going to use the third representation, 4 over 32. So let's actually erase that 4 and write it better. 4 over 32. And I'm going to simplify that because both numbers are divisible by 4. So divide 4 from the numerator. Divide 4 from your denominator. That is going to equal to 1 over 8. But this is the ratio of 1 to 8. So odds in favor of sum of 9 is 1 to, here's the word 2, 8. I know it's a lot of writing, but I wanted to make sure it was real detailed for you guys. All right, that's it for this video. We're 3/5 of the way completed. I'll catch you in the next one. Take care.